Good morning, class. This is Mr. Sadler coming to you live from the internet on Wednesday, April the 29th, 2015. I'd like you to play along. I'm going to call for people today. The rumor is also that not everyone listens to these videos, and if you don't, I'm a little disappointed. You guys are an awesome class, and it takes me a little bit of time in preparation to do these videos here. So if you wouldn't mind just actually focusing here. I'm going to do this video, will be about half of the class, and the second half of the class will some time for homework. So if you need to talk to your neighbor at that point, or be on your phones and all that stuff, please do so then. Okay, so what we're going to do today is we're going to talk about the intro to trigonometry. What I'm hoping to get through today is sine law, cosine law, SOHCAHTOA, and sine law and cosine law. Let's talk then a few basic things about trig. Number one is this. Mr. Sadler can't draw triangles. Okay, how does that impact you as a student? Well, this is how. Thus, please use calculations rather than measurement. And I wish I was kidding about this, but I'll draw a triangle that looks like this, and I'll say, okay, that side's 2 and that side's 123. All right, clearly those aren't in the same proportion of 223, but that's fine. Let's talk a little bit about a few things you need to know about me for triangles. This is a special type of triangle right there. Can I get a brave volunteer? I'm going to start here with Liam. Liam, can you tell me what type of triangle that is, please? Okay, good. This is a right triangle because this is a right angle. Olivia, what does a right angle mean? Okay, awesome, 90 degrees. Right angle triangles are good for lots and lots of things. First things first is going to be, I put an A, a B, and a C. Okay, we can do what's called the Pythagorean theorem. Okay, and Elena Waller, if you can tell me, please, what the Pythagorean theorem is, please. Okay, great. A squared plus B squared equals C squared. And this is, of course, your hypotenuse. Okay, so that will tell us on any right angle triangle, you can find any side if you're given the other two. This will lead us nicely into example 1. It's going to be solved for x. We're going to put a beautiful right triangle. There's going to be 13, there's going to be 5, and there's going to be x. Okay, so I'd like the supply teacher to please hit pause, and as we're going through this to Mr. Tozer, I think it's going to be in you there today. If not, I apologize for using your name. Hit pause every time anyone looks lost or isn't paying attention or what have you. I want you guys to get through this. So take a minute here now, please, and solve this question, and then I'll take up the answer when I get back. Okay, great, thanks. Here's the solution. It's going to be x squared plus 5 squared is equal to 13 squared. All right, Marissa, why did I not keep the x by itself? Why did I say x squared plus 5 squared equals 13 squared? All right, good. Hopefully what you said was because 13 is the biggest side. This is your hypotenuse right here, right? Right, so that's going to be alone on the right-hand side. So I'm going to call that x squared plus 25 equals 169. X squared is equal to 169 minus 25. X squared equals 144. X equals 12. And I got a call, so I'm going to pause here. I'll be back in a sec. Okay, sorry about that, we're back. And again, this answer makes sense because the x on the left is 12 and the two opposite sides have to be shorter than the hypotenuse. All right, let's talk a little about angles for a sec. We're going to say in math class, letters represent side length. When Greek letters represent angles. Okay, some of these you'll have seen before in grade 10. Some of these you won't, so I'm just going to go through the list of the common ones that I will use. The first one here is going to be that right there, and that's going to mean theta. The second one is a B with a little bit of an extension, and that's going to be called beta. I'm hoping that's omega, and if it's not, please tell the class there, please, Mr. Tozer. But those are the three that I'll use. Okay, so whether or not I use the names or not, but those will be the three angles that we use. Some nice rules about angles is that all angles all interior angles of a triangle add 280 degrees. Okay. Also, I'm going to just do the C pattern, the F pattern, and all that stuff. Okay. So here's going to be, those are parallel lines, not a parallel those look. Okay. So the first pattern I'm going to mention here is going to be the F pattern, where there's your theta and there's your theta. They mean the same thing. Next one's going to be the Z pattern, once again being the parallel lines. We have theta is equal to theta. We have theta and 180 minus theta. We have, once again, theta and theta. And finally, the C pattern, which is going to be, there's your theta and there's your 180 minus theta. Again, Mr. Tozer, if you want to go into any more detail on any of those things, that'd be great, but that's basically all the angle rules that we've used so far. Okay, on to SOHCAHTOA. As I said, this is going to be fast and furious, so if you need to pause any of the way through, Mr. Tozer, please do so. This is used to find the side length or angle measure. In any right-angled triangle. Okay, and if you didn't have to memorize in grade 10, if you didn't have to memorize this in grade 10, you'll have to in grade 11. So what these are just doing, they're just setting up our ratios here. And where these actually came from were sine and cosine tan are actually measurements that people have taken that compare the ratio of two numbers. Okay, so sine of theta is going to be the opposite side divided by the hypotenuse. Cos of theta is going to be the adjacent side over the hypotenuse. and tan of theta is going to be the opposite side over the adjacent. And if you look at the first letters of op, hip, and adjacent, that's where the O and the H, the A and the H, the O and the A come from. All right, here we go, example 2. I will work this one for you, and then you guys can try the next one for me. So example 2 is going to be, once again, solve for x. Okay, so here's my beautiful right-angled triangle. There's my x, there's my 15, and there is 40 degrees. All right, so when you see these types of questions, first of all, we want to label opposite and adjacent and hypotenuse. And this is always something that's a little bit tricky, so I'm going to take a second to make sure we get this before we go. If 40 degrees is my key angle, which it is, opposite is going to be the one directly across from it. Leah, what side will be directly across from 40 degrees, please? All right, good, that's going to be x. Hypotenuse will be the longest side, meaning that it's across from 90 degrees. Alana, what's that going to be, please? Hypotenuse. And I used to just say that the leftover side was adjacent, but when I was teaching applied math, my EA had good observation that adjacent will always be the angle between, always be the side between the angle and the right angle, and that's good. All right, so now do I use sine or cos or tan? Okay, well, Summer, which one is it going to be? Okay, it's going to be sine because we know something about theta, which is going to be our angle, our opposite, and also our adjacent. All right, Hannah, can you sub some numbers in for us, please? So we're going to say good, sine of 40 equals x over 15, great. Austin, can you solve for x, please? Okay, we're going to multiply the 15 over, good, so it's going to be 15 times sine 40 equals x. I'll do this on my trusty calculator. I'd like everyone to take out their calculators right now, even those that are rudely not watching my video right now. Hopefully that's nobody. And what you're going to do is I'd like you to type the following things into your calculator. Okay, so if you guys have a super duper calculator, well, that's for some reason pausing on me. If you have a super duper calculator, you can do it all in one step. But if you have an old calculator like me, what you're going to do is, first of all, you're going to make sure your calculator's in degree mode, and then you're going to type in 40 sine, or sine 40. And you should get a number of 0.6427876.096, ... Of course, your calculators won't go that far. So take a minute here, please, and Mr. Tozer, if you can hit pause on the video, and make sure that everyone can get 0.6427 ... on their calculator. If anyone is unable to, please raise your hand, and Mr. Tozer will run around and make sure that you can get that. So that's what sine of 40 is. I'm going to times that then by 15. And I get an answer of 9.64. You know, again, that answer makes sense because your hypotenuse is 15. The opposite side has to be less than that. Okay, let's try example 2 here right now. So example 3, excuse me. On example 3, I'm going to hit pause in the video and give you guys a chance to work on this. So example 3 is going to say solve for x. Okay. And I apologize for the triangles. I'm doing my best. I know you don't think that I am, but triangles for some reason are very difficult for me. There we go. So there's a right angle. We have 31 degrees and we have x. If you don't know how to get started, label the triangle, opposite, adjacent, hypotenuse. Okay, and please hit pause, Mr. Tozer, and give the class a minute or two to try this one out to make sure they can do it. For those people that are rudely not doing this, take your calculators out and do it. Okay, great. We're up to Owen. Owen, can you please, if 31 degrees is your key angle, can you tell me what's opposite, adjacent, and hypotenuse from that, please? Okay, good. Opposite's going to be over here. Adjacent's at the bottom. Hypotenuse Adria, will I be using sine or cos or tan right now? Okay, good, cos. Because cos of theta, I'll write that. Excuse me. Cos of theta is going to be adjacent over hypotenuse. We can ignore the opposite side because it doesn't help us in any way. All right, Nicole, can you sub the numbers in for us, please? Okay, good. Cos of 31 equals 11 over x. Now, I intentionally was mean on this question, okay, because I'm mean like that. Luke, it's up to you to solve for x. I don't like that divided by x. How do I get rid of that divided by x? Okay, wonderful. Hopefully he said multiply by x. So it's going to be x times cos 31 degrees is equal to 11. So x equals 11 divided by cos 31. Okay, I'm going to get Mr. Tozer to hit pause right now and probably re-explain that because there's half the class looking at that saying that's weird. Don't mind me talking like a kid. That's what my daughter says, that's weird. Okay, so now hopefully we're good. And I'm just going to do 11 divided by 31 cos. And 31 cos should be 0.85716 dot 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 dot. Get equals, and you get x equals 12.83. So take a second and make sure you can get that number. If you don't have a calculator today, shame on you. Bring a calculator from now until the end of the year every single day. All right, because you're going to need one. Okay, let's move on to solving for angles now. Okay, which is a little bit more awesome, but still very doable here. We're on to example 4. Example 4 says solve for theta. I'll take you through this first one. You guys can do the second one yourselves. Oh, it's a messy looking triangle. Yeah, 18 and 16. Okay, we're up to Noah. These questions are all going to start the same way. Can you label opposite adjacent hypotenuse for me, please? Okay, good. So opposite is 16. Adjacent is going to be this unknown sign on the right, and hypotenuse is going to be there. All right, Kylie, since I have opposite and hypotenuse, will I be using sine or cos or tan? Okay, good, sine. So I'll say sine of theta is equal to opposite over hypotenuse. So I'm going to say then finally, sine of theta is 16 over 18. All right, so I want to get theta by itself. Alex, since you were in grade 10 last semester, how do I get rid of that sign from the left? No, you don't divide by sine. Oh, Alex. No, I'm just joking. What you, of course, said was you do sine inverse. And you remember the inverse function from earlier in the course? Okay, it means like the opposite function. So instead of giving you a decimal, this, if you put in a decimal, it's going to give you an angle. How you get that on your calculator is, on my old calculator, I would hit clear first of all, making sure I'm in degrees again. I would do 16 divided by 18. And then there's going to be and you get a decimal 0.888 forever. And then you're going to have a shift or a second or an inverse. I have an inverse function right there. And I'm going to do sine inverse. And I'm going to get 62.73 degrees. So what I did here, if you need me to write that down, was I did second sine or shift sine or whatever. Because basically on every calculator in the world, it looks something like this. Okay, that's what your calculator button will look like. Okay. I'm going to pause for a sec. I'm going to rephrase here. I'm going to get you guys to do the next example by yourselves, and then we'll move on to sine law. So example 5, excuse me, says solve for theta. Theta, yeah, I'll do theta. Okay, so it's going to be 28 and 15. Okay, so if Mr. Tozer, if you can hit pause, please, right now, we'll give the chance of the class a few minutes to work this out. It'll be good. Okay, Bailey, you're going to be up first here now, please. Can you label this opposite adjacent hypotenuse, please? So the opposite is? Okay, good. The adjacent is? Great, and the hypotenuse is going to be here. All right, Quinn, I have opposite and adjacent. Am I using sine or cos or tan? Very good. So it'll be tan of theta equals opposite over adjacent. Sub some numbers in. Tan of theta is 28 over 15. All right, Jennifer, how do we get rid of the tan now? You just want theta equals. Awesome, great job. Tan inverse of 28 over 15. Okay, I can't do that in my head, and probably not too many people can. So I'm going to go to my trusty dusty calculator. I'm going to do 28 divided by 15 equals, and then second or inverse 10. I should get 61.82. By the way, if for any of these calculations you don't get the same answer, be brave and ask Mr. Tozer to show you how he got it on the calculator to help you get it. He is a really nice guy. Okay, this is what he does for a living. He loves math. Okay, so this is wonderful. All right, I'm going to move on to sine law, and then we're going to stop for today. Okay. How much is video going on? Yeah, 21 minutes. Only me and my wife will watch this. Next one's going to be sine law. You guys are just kidding. You know she doesn't watch math. Okay, sine law was created because there are some triangles in this world that are not right angles. All right. So for sine law, what happens is I'm going to label the three sides. I'm going to make a triangle like this. I'm going to call this angle A and side A, angle B and side B, angle C and side C. And our equation for sine law is going to be sine A over A equals sine B over B equals sine C over C, or A over sine A equals B over sine B equals C over sine C. Now remember, when you're doing this, I gave you two versions of the same equation, both one's flipped compared to the other. The reason for that is you always want to put your unknown at the top left. So if I'm solving for an angle, I'll want to use this one here. If I'm solving for a side, I'm going to use the bottom one there. Okay. Here we go, example 6, and this should hopefully be coming back to your memory. So example 6 is going to be solved for x. Okay, so I'm going to put a nice, beautiful question sort of like, oh goodness, that's a heck of a triangle. Okay, so I have 48 degrees, 61 degrees, an x and a 10. Okay, so I'm going to start with my unknown. Okay, so I'm going to start with x. Okay. All right, Adam, what angle is related to x? Okay, good, 48. Okay, the reason that we know that is we're dealing with opposites always in sine law. Okay, so it's going to be x related to sine 48. All right, what's the next side going to be here? Riley, go ahead. Okay, good. So we're going to have 10 over sine 61. Okay, so this is looking good, but not yet great. Skylar, I want to isolate x. What do I need to get rid of? Okay, good. The sine 48. So it's going to be x equals 10 times sine 48 divided by sine 61. By the way, I'm going through this relatively quickly. If someone is not clear and raises their hand, Mr. Tozer, please go and help if necessary. All right, so how I do this on my calculator then, I'd like you guys all to try this on your calculator. how I'm going to do it on mine is 10 times 48 sine divided by 61 sine equals, and I get 8.50. And hopefully you will too. We'll try this one more time. Okay, 10 times 48 sine divided by 61 sine. All right, I'm going to get you guys to try one for me right now, which is going to be example 7, which is going to be solve the triangle. That's going to be all sides and all angles. So the triangle I'm going to give, let's get a beautiful triangle. Goes something like this. Now looking at that, you're probably thinking to yourself, holy Hannah, I'm never going to be able to solve that triangle. You will, okay? We're going to, I'll help you get you started here, and then we're going to hit pause. The first thing I want to solve is that theta. The reason I have to solve the theta in the bottom right is that because 11 will be connected to the 61, so your unknown angle will be related to 10. I'd like you to pause the video for me right now, and then Julia will give me the first step momentarily. Okay, Julia, go ahead, please. I'm going to start with my unknown angle, which is sine theta. What side is connected to sine theta, please? Make it 10. Excellent. Emily, what's my other angle, please? Good, sine 61. What angle, what side related to that, please? 11. Great. All right, Tristan, I want to isolate theta. What's the first step, please? Thank you. I'll move the 10 over. So good. Robin, I want to get rid of the sine. So I'm going to hopefully do theta equals sine -1 of all of that mess. I'm going to show you how I do that in my calculator, okay, because, whoops, I should probably leave that there. I'm going to show you how I do that in my calculator because, again, if you have a super duper calculator, you can do it all in one step. Okay, but for me, I can't. So what I'm going to do is this. I do the inside bracket first. I'm going to do 10 times 61 sine equals divided by 11 equals, and then do inverse sine. And I get 52.67 degrees. So I'm going to show you one last time a little bit slower to make sure that we're good. So I do inside the brackets first. So I'm going to do 10 times 61 sine equals divided by 11 equals, and I'm going to do inverse sine. You get 52.67. Now you're probably saying, yeah, wonderful, Mr. Sadler, I could do that. I'm brilliant at math, but I don't know how to solve the rest of it. Let's keep going for beta, because that's got to be the next thing. And I'll put x in there as well. All right, Matt, how do you solve for beta? Okay, awesome. What Matt said was all three angles are going to add up to 180. So beta is going to be 180 degrees minus 61 degrees minus 52.67. We're using the law here that all three interior angles of the triangle add to 180. Okay, so I'm going to do that on my calculator here, so don't make a mistake. 180 minus 61 minus 52.67 equals 66.33. Okay, great. And that's looking tremendous even. Okay, Carissa, you're up. I want to solve for x, so I'm going to start with x as my unknown on the top left. What angle is related with x? Okay, wonderful. It's the opposite to that, so it's going to be 66.33 degrees. Okay, good. Okay, Grace, what other set of sides are you going to use? Now, I can't actually read your mind, so I'm going to assume that you're using 11. Okay? The reason I'm going to use 11 is because 11 and its opposite angle are already given to us. Okay, so Grace, I'm going to do 11 over sine 61 degrees. All right, Cole, can you please isolate x? What do we do, please? Okay, good. Equals 11 times sine 66.33 degrees, all over sine 61. Great, and Brad with your super duper new calculator. Second, calculate that out for the class. So while Brad figures out how to use his calculator, we'll do this up here. So it's going to be 6.33 sine times 11 equals divided by 61 sine equals, so I get 11.52. Hopefully you guys get the same answer. All right, now if you notice, that worked out almost like I planned it, which I didn't, but every student in the class has a chance to raise their hand once today. That's wonderful. All right, I'm going to hit pause in the video here, then I'll give you your homework, and then we'll keep going. Or then we'll stop, I guess, for you guys here. For Mr. Tozer, if there's still half an hour left in the class at this moment, and not everyone has their books, and you just want to write some examples on the board, I can or steal the textbook from somebody and write some questions from the board, that's fine for that. So I'm going to put the homework up right now. Here we go. Okay, I got that homework for you. It is page... Actually, I'll go to the next board. Okay, Pythagorean theorem is page 548, number 3. SOHCAHTOA is page 572, number 3, 4, 5, 8, 9, and Sine Law is page 575. Number 1, A, B, E, F, and 2, C, and E. Okay, that's it for today. Thanks, guys. I will digitally see you tomorrow. Digitally? Easy for me to say. Thank you. Okay, bye.